Hello, in this video we're going to be discussing atomic spectroscopy. And so atomic spectroscopy can basically be boiled down as the process by which light interacts with electrons and the movement of electrons up and down energy levels. And we're specifically going to stick to hydrogen in this case. As you can see, I have Bohr models of hydrogen here in the video, and that's because hydrogen is simplistic and it works for these calculations much more so than you could say for other elements. As elements and atoms get more complicated, this math drifts further and further away. But the math does work for hydrogen, so that's what we're going to stick to. So essentially spectroscopy can be broken down into two different camps: absorption and emission. And we're going to focus on absorption first. So just to recap, remember that photons are particles of light, and photons have energy associated with them, and that energy can be represented in the Planck equation as being equal to the Planck constant h times frequency, which is this letter nu, which looks kind of like a V. And we'll introduce the second equation called the Bohr equation in just a second. But in the process of absorption, a photon of light is going to interact with an electron. In this case, we have an electron existing in the second energy level, the second shell, and we have an electron there. So this photon of light is going to come in and interact with this electron. And what's going to end up happening is the energy associated with this photon is going to be transferred to this electron. And that energy transfer is going to cause this electron to be pushed up one or more energy levels. Because remember, energy can't be created or destroyed, it has to be transferred. So the energy that comes from this photon, represented by this squiggly green line, is going to cause this electron here to go up either one or more energy levels, depending on the energy associated with the photon. So that is the process of absorption, which makes sense because think we're absorbing. We're absorbing the energy of that photon into the atom, and that's causing that electron to be pushed upwards towards the higher energy levels. Because energy is required to push electrons up energy levels. And the energy is going to come from that photon that enters in. And then we go over to the topic of emission. So emission is the opposite effect. The process of emission is going to be caused by an electron. Again, we have it in the second energy level here, but it could be any energy level. Just hypothetically, let's say it's in the second. So let's say we have the same electron in the same energy level, and if that electron were to be demoted to a lower energy level, if it were to fall downward to a lower energy level, well, that process is going to give off energy. And it's going to give off energy in the form of a photon. So depending on how far it falls down, how much energy is given off, is going to affect the photon that's given off. But just to sort of define it, emission is where an electron drops energy levels, and the drop in energy level is going to produce a photon of light. It's emitted. So emission involves the emission of that photon of light. And emission is quite interesting because you can look at the spectral lines of elements. So each element is going to have an individual spectral line of emission. So certain elements emit certain wavelengths of light, i.e. the photons, and you can look at the spectral lines of elements and determine which element they are based on the wavelengths of the photons that they are emitting, which is really interesting. So that's absorption and emission, and they're tied together with this equation here, which is the Bohr equation. And that's because Niels Bohr had a lot to do with atomic spectroscopy, as we talked about with the Bohr model. So Niels Bohr did a lot of work with absorption and emission, and he determined this equation here could be used to determine the energy associated with energy levels. And we'll see this when we want to calculate wavelengths associated with photons in both the absorption and emission processes and the energy associated. So we'll look at that in the next video, where we'll do some practice problems involving the Bohr equation with both absorption and emission. So just to recap, absorption is the process by which the energy of a photon is transferred to an electron, which will push that electron up one or more energy levels in the atom. And emission is when an electron drops one or more energy levels and the energy produced is emitted as a photon.